once again the voice of Professor Kaku. Professor, welcome back to the program.
Art, glad to be back on again.
Happy to have you as always. All right, I'm going to lay it out for you, and I'm going to ask you just the way I asked the audience. Right now, if you read tonight's news, let's see, there's a story about Iraq planning to destroy all its oil fields, food supplies, power plants, kill a bunch of civilians, and then blame the whole damn thing on the U.S. bombing should a war begin. There's another story about our president who says now Saddam has missed his last chance to come clean with the world. And they're saying that there may be a material breach on the 12,000-page document turned over. They found a material, or they're arguing about whether there's a material breach. It looks like president's going to war. Gold just went higher than it's been in a whole long time. The economy is in very tough shape, anticipating the war. Seems like war is absolutely inevitable. We're doing this little dance with the UN, but Britain is actually beginning to mobilize their troops now. It looks certainly like war to me. And I was asking my audience the following question. I think it's a really good one. So far, I've heard it said that Saddam has weapons of mass destruction, or might have them or something. But we haven't been shown the proof of that specifically yet. I sort of feel that if he's got them, and we know he's got the intent to use them, then there might be justification for us to be going to war. But if people aren't told actually why they're going to war, I don't know that they'll like that. And history has shown that the American people don't like it when we go to war and we don't understand fully why we're doing it. That's a pretty good precedent back there in Vietnam. And my question to you is, are you willing to support this country, America, going to war against Iraq, even though you do not specifically understand why we're doing it? In other words, we know what they've got. Even if we gave it to them or some stupid thing like that, whatever. Do you have enough information now to say we should be going to war?
I think you asked the big question. Winston Churchill once said, if you're about to go to war, you have to understand the full consequences of what you're unleashing on the world. Two things. First of all, there could be a backlash against us throughout the Middle East, even bigger than the one that already exists. And just remember that Pakistan is just barely holding on right now with the pro-Western government. And if the government of Pakistan is ever toppled, just remember that they have about 20 nuclear weapons in Pakistan. You can stop talking about half-assembled or quarter-assembled atomic bombs or pieces of atomic bombs. Pakistan has about 20 fully assembled atomic bombs that could fall into the wrong hands.
Do you have any idea how big they are, by the way?
These are Hiroshima-sized nuclear weapons. About 5 of them were detonated several years ago in the face of India's nuclear weapons, just to prove to the world that Pakistan can, in fact, detonate Hiroshima-sized atomic bombs.
So they would be bombs that would destroy an entire city.
That's right. We're talking about approximately 20 kilotons, 20,000 tons of TNT. Yeah. Imagine 20,000 boxcars of dynamite. That's several miles long caravan of dynamite. And that's what you can do to a modern metropolitan city. And Pakistan has on the order of about 20 of these nuclear weapons that could fall in the wrong hands. So there's a lot at stake, not to mention, of course, the government of Saudi Arabia, Egypt, and Jordan, all pro-U.S.
Well, no, wait a minute there. I'm not so sure about that. I don't think, Professor, Saudi Arabia is pro-U.S. at all. They give a little bit of lip service to that, but frankly, Saudi Arabia has financed a lot of the nasty doings that have gone on. They really have.
Yeah, but take a look at the big picture. The big picture is that we have relative stability there because Saudi Arabia has a hand on the spigot, as they say.
Oh, they do.
And so far, it's been relatively stable for the West.
Yeah.
So I think we have to look at the second big issue, not just the consequences of what happened to Jordan, Egypt, and Pakistan get destabilized. We also have to look at the 800-pound gorilla in the room. Let's not dance around this or that. Let's talk about what's really at stake, and that is oil. That's how we got into this mess when Saddam Hussein invaded Kuwait, who to take control of the oil supplies in that area. Yeah. It's really about oil. That is the architecture of our U.S. foreign policy in the Middle East. That's what it's all about. And my particular point of view is that we should gradually wean ourselves away from oil. Oil gets us into big trouble. Oil exacerbates the greenhouse effect with global warming. Oil also puts us in bed with dictatorships like the one in Egypt and feudal monarchies like the one in Saudi Arabia. Oil gets us into big trouble because that's what this whole war is really all about when Saddam Hussein invaded Kuwait about 10 years ago. And that's why I think that what we really ought to do, if we're really serious about this,
Yes.
we really ought to embark upon a national program to start to get into a solar hydrogen economy. A solar hydrogen economy would make us less dependent on the most unstable regions of the world. I can't think of a region of the world more unstable than the Middle East. And here we are, our jugular vein.
Let me stop you for a second. A solar hydrogen economy. Tell me as much as you know about how economically feasible, viable, and really clean it would be. In other words, you use solar power to separate and create the hydrogen, which you then store and then people use as fuel. Is there any hole in that idea anywhere?
The only hole is not a technical one. The only hole is economics.
Okay.
Right now, solar hydrogen is within striking distance of electricity. It's not there yet. We're still talking about prices that are maybe 50 to 70% more expensive than you can get from oil and coal.
70%.
However, that's because it has to be jump-started by mass production. Take a look at nuclear energy. The only reason why nuclear energy got off the ground is because the U.S. federal government subsidized, to the tune of about $100 billion, research in reactor safety, the nuclear fuel cycle, and jump-started nuclear. The same thing with solar hydrogen. If you give tax credits and research and you jump-start this technology, then you could begin to create a mass-produced technology which would reduce the cost by about 50% and make solar hydrogen competitive with the electricity coming from the Middle East.
How do you sell this idea to an oil man?
Well, that's the whole trick. The Bush administration, let's face it, George Bush's whole family tree comes out of oil. They are Texas oilmen inside and out.
Well, they bleeds oil and then maybe a little blood.
Right. However, it may be forced upon us. In other words, I think that we will go into a solar hydrogen era, not because we want to, but because there's going to be massive instability in the world, which will force us to go to a solar hydrogen economy. The Middle East, that is a tinderbox. It could blow up at any time.
You mean you think it's going to get so bad that there's going to be like a cutoff, which they did one time before? Something at least that drastic is what you're saying? That they're going to get together and they're going to say, the damn warmongering United States, we've had it, no more oil. You think they'd do that?
I think there could be massive disruptions in oil, and it could be a real wake-up call when we realize that the feudal monarchies of the Middle East that have been reasonably stable in terms of giving us the oil, they may begin to listen to the angry voices out there in the mosques. And when that happens, they may decide to turn off that spigot for a while just to see it squirm. And at that point, we're going to say to ourselves, oh, my God, we should really think about this solar hydrogen alternative rather than being so dependent on oil from the most unstable region of the world.
Let me just circle back to the question so it doesn't get lost, because we're going down a lot of good places, but I really do want to get an answer to it. And that is, do you either publicly or through private channels know enough so that you would say are going to war against Saddam Hussein to go in and ostensibly destroy whatever weapons of mass destruction he has, whatever it is we're going to do in Iraq? Do you know enough that you would say a war is justified?
I've been reading everything I can about what's there.
Yeah,
so far, there is unanimous agreement among nuclear experts that Saddam Hussein does not have a nuclear infrastructure. It was pretty much dismantled during the last Gulf War of '91. Whether or not he has chemical or biological weapons is much more difficult because, of course, you could put a lot inside a vial of liquid, and the infrastructure is much smaller.
But you're pretty sure there would be a consensus of those who know that there are not yet nuclear weapons there.
Yeah, that's pretty much the universal consensus between hawks and doves, that he does not have a nuclear infrastructure, because, of course, it would require billions of dollars to maintain this, to enrich uranium and process plutonium. Chemical and biological weapons, you get into a gray area. And I personally, to answer your question, I personally am not totally convinced that we have the smoking gun.
Yeah.
In other words, we don't need a lot of bluster. We need just one solid fact to convince the man in the street, especially the man in the mosque, to convince these people that Hussein has been cheating his pants off. And I haven't seen it yet. Now, that doesn't mean that he hasn't been cheating. Right? God knows he's cheated before. All I'm saying is that I haven't yet seen the smoking gun.
Well, then you answered my question exactly the way I answered it for myself. We just haven't. We haven't had the goods laid on us yet, and I don't know how much support there's going to be for whatever we're going to do if they don't do that. And maybe it's embarrassing. And maybe we gave them, who knows, some godforsaken bug that will crawl back to kill us. Maybe we did. But even if we did, I think we need to come clean.
I think scientists as a whole during the Cold War did investigate all sorts of hideous designer germs. They played with smallpox. They played with dengue fever and Rift Valley fever and all sorts of incurable diseases.
Did you hear the First Lady the other day?
No.
She was on the news that we were on here at the top of the hour saying how I wouldn't hesitate for a second to get my children smallpox vaccinations. When the First Lady says something like that, that probably means something.
Yes, I think we're paying the price in some sense for the excesses of the Cold War. The only place where Saddam Hussein might have gotten some false smallpox is from a renegade doctor in the Soviet Union. And I think that's one of the prices we now pay for all the scientific devilry that was cooked up during the Cold War between the Soviet Union and the United States. With the Soviet Union breaking apart, a lot of that technology is slowly leaking out. And I think that let's hope that we can contain some of these renegade scientists and materials from leaking out of the Soviet Union anymore.
Do you know anything at all about if we were attacked with smallpox? Professor, do you have any idea how bad it could be?
I'm in New York right now. I'm in Manhattan. And we had these outbreaks years ago that was contained by a massive, absolutely massive vaccination program that was initiated almost immediately. And it shows that, yes, if you have the will and you have the dollars and you're willing to vaccinate hundreds of thousands of people almost instantly, then perhaps you can contain an outbreak. However, if someone were to deliberately infect a nation that is unprotected,
in many places at one time.
That's right. Vaccination itself is risky, and there are people who should not get vaccinated, people with medical problems and even eczema, a skin disease. And I think that it's a pretty nasty germ. Look what it did to the Native Americans who were not protected, right? Up to 90% of them were wiped out after Columbus. So I think that it's a pretty nasty germ that we're dealing with here. We're the biggest killers of humanity.
Well, in other words, it really could be devastating. It really could take off in a bunch of places at once if they came after us that way.
But if you were Saddam Hussein, or if I were Saddam Hussein, right, the thinking is that he probably had sleeper agents around the world to unleash all sorts of devilry just to spite the United States, to get back at the United States, but he's a cornered rat. Sorts of strange things.
Did you happen to hear the other day where the United States again reiterated the fact that anybody uses any weapon of mass destruction on us at all, and that's they were referring to that kind of thing exactly. We would not hesitate to use a nuclear weapon. We said that quite loudly a few days ago.
That's right. So remember, if Saddam Hussein's going to go down, he may want to take a few million Americans with him. And I think that he certainly has the potential, if in fact he got access to smallpox or got access to mustard gas.
So then in answer to the question, you're saying that an intentional attack, could cost a few million American lives. Few million is what you're saying, right?
The worst case scenario. Okay?
That's pretty bad.
As Winston Churchill said, when you go to war, you have to know the consequences of the forces that you are unleashing. And Saddam was saying if he's cornered, well, during the last war, we now know that he did not unleash a lot of the chemical weapons and biological weapons that he had because, of course, that would be the coup de grace, and that would be the end of Saddam Hussein. So he held back.
That's
this time, knowing that he's going to die, knowing that he's going to go down, he's not going to hold back. And we have to understand the consequences of this, both politically in terms of the stability of Pakistan and Jordan and Egypt and Saudi Arabia, but also militarily in terms of the fact that this corner dictator could unleash lots of stuff if he knows that he's going to go down too. We have to be prepared for that.
What would you do?
I said, I would
About the
try
alternative.
to do the bigger picture, oil, and also the United Nations. It's kind of a joke, the United Nations.
It's a dance.
So many resolutions.
Oh, it's a big dance working through.
If the United Nations had been strengthened in the last 10 years, these resolutions would not be laughed at by Saddam Hussein. They'd be taken seriously. But unfortunately, I think we've sort of let the United Nations atrophy. It's issued all these proclamations saying that Saddam Hussein should disarm. He's laughed at us. And now we find ourselves in big doom. I think we're paying the price for allowing the United Nations to atrophy because now we're trying to prop it up.
All right, hold it right there. We're at the bottom of the hour. We've let the UN atrophy, huh? Now we're paying the price. I'm Art Bell from the High Desert. This is Coast AM.
You're listening to Art Bell, Somewhere in Time. Tonight featuring a replay of Coast to Coast AM from December 18th, 2002.
I think it's about me. And then one thing. Oh, no.
You're listening to Art Bell, Somewhere in Time. Tonight featuring a replay of Coast to Coast AM from December 18th, 2002.
War, nearly certain war. That's certainly something that'll put you on the ground and think about it for a little while. War is coming, definitely days, probably weeks, but really, really soon. So it's on the way.
That's about what they're doing. That.
On December 15th, CNN reported a large triangular object hovering over Baghdad, I am told. Now, that's very interesting. Isn't that interesting? In fact, I actually managed to get a camera shot, I understand, of something triangular hovering over Baghdad. Not to be confused with the green tracers that were fired at it, but somebody saw something just hovering, described as looking like the Phoenix Lights over Baghdad. I thought that was pretty interesting stuff. You got to wonder about the kind of craft we have. I don't wonder. I saw one of these things close up myself. It either was defying gravity or, well, I don't know. I saw one of them out here, though, and they put something over Baghdad. Is there little question in your mind, Professor, that war, in fact, war is coming?
I think all the indications are that the Bush administration wants regime change, as they say, as the foundation of their foreign policy.
Yeah.
And it does look like George Bush is hell-bent on war. Regardless of the outcome of the UN inspections, I think he's gearing up the U.S. military for war.
How much do you know about the high-tech toys that we have or probably have, Professor, that we could bring into play if the inevitable occurs?
The biggest change between now and what happened in 91 is the fact that our munitions, rather cheaply, $20,000 a piece, can be outfitted with GPS positioning devices. Back in 91, things were done by lasers, and if it was smoky or it was foggy, the cloud cover would disperse the laser beam. Lasers don't go very well through fogs. However, radio does, and GPS systems can lock onto satellites. And these GPS devices are very cheap. They only cost about $20,000, and you could take a dumb bomb and, quote, make them smart by inserting one of these portable GPS positioning devices on them. And so about 10% of our munitions dropped during the Gulf War were smart, and 90% were dumb. In this war, it could be the reverse. It could be that most of the munitions will be smart, that is GPS guided. But I think that, there could be potential danger there. We could begin to believe that our weapons are so smart that they work all the time. And of course, that's not true. We see bombs falling into schoolyards and hospitals all the time.
And even if that doesn't happen, tonight's headlines say Saddam is prepared to crank out casualties, destroy his own infrastructure. Actually, the scorched land policy, have you heard about that?
I can put yourself in his position. If he's a quartered rat and he's going to go down with the ship, you want to take as many of us as he possibly can to make his mark on the history books. But I think he's sort of resigned himself now that he's going to go down. And if so, he wants to take as many Americans with him as he possibly can.
Well, how do you feel about living in New York?
I live not that far from the World Trade Center.
Yeah.
And it was, of course, rather shocking when the whole thing happened, and sort of makes you feel vulnerable. Great ocean.
Yeah. In the case, though, of these bugs that might get released, New York, Washington, Los Angeles, Chicago, and then on down the list from there, I suppose. You can be like New York is going to be like first.
Yes. Unfortunately, that's one of the prices of living in the great metropolitan center of New York City. And that is that there's one of the most densely populated areas of the entire country. 8 million people lie within the boundaries of New York City. And even if you chop up Brooklyn, Brooklyn would be, I think, America's second largest city if you just chop up New York City. So I think we have a tremendous...
That's what I think he has in mind, chopping up New York City.
Yeah, I think that's something that we have to come to grips with, and we have to say to ourselves, is it worth it? The instability in the Middle East, not to mention the instability in our own cities, if something like this happens.
Maybe it's worth it. I feel like I haven't been given enough information yet to make that judgment about whether it's worth it or not. For sure, if we knew he had some awful thing and he absolutely had the will, in fact, the intention to let loose on it, then by all means, kick his butt first. But I don't think we're anywhere close to that standard of proof yet, or at least not publicly.
And I also think, going back to the United Nations, our favorite whipping boy, this is going to happen again. And now Iran, apparently, is building nuclear weapons. That was
So I've heard.
the wire service just a few weeks ago.
Yeah.
Look at North Korea. We're going to be going to the same song and dance over and over again.
Didn't we always know that was coming? Right. Proliferation, we knew that, right?
That's right. And again, this is one of the prices we paid for the Cold War, when we allowed this technology to escape because they would be anti-communist weapons. And now we see that they're falling into all sorts of different kinds of hands. For example, North Korea, we now know, got most of its uranium technology from Pakistan. And Pakistan, in turn, was allowed to get this technology because Pakistan was against the Soviet Union in Afghanistan during the Reagan years. And so a lot of nuclear technology flowed into Pakistan during the 80s under Ronald Reagan, which now is flowed into North Korea, all in the name of anti-communism.
The big problem is that today's friend almost always turns out to be tomorrow's enemy. And it just happens again and again. So if we allow some country for political reasons, because we're friendly, to get weapons now or did then, well, then it may well be that in a few years they won't like us.
Well, that's what happened. We armed the Afghan rebels. You know that, right? $1 billion.
All those shoulder-fired missiles and everything.
They got their Stingers.
Oh,
Stingers can take out an airline, commercial airline. That's what a Stinger missile can do.
Oh, we're worried about that right now because, of course, they shot at one and they missed, but those missiles are out there. They're definitely out there.
Our biggest enemy is U.S.-made weapons. U.S.-made weapons that fell into the hands of the Taliban because we gave it to them during the Afghan war.
Well, aren't we the biggest producer of big guns?
Yeah, that's right. And that's why we have to worry about what happens when our own weapons eventually fall into the hands of terrorists. That's why during the Afghan war just last year, that's why our jets had to fly so high. You could barely see them up there. And the reason is they were fearful of U.S.-made Stinger missiles taking them out. And I think this is a tragedy that's not told to the American people, that our own military is absolutely frightened of U.S.-made weapons like Stingers.
Well, we make good weapons, so we should be frightened of them. But I guess we've got to say a few generations ahead of what gets leaked out to them. That's a crazy world, but that's not the truth of it, isn't it?
But we have to realize now we're pushing nuclear. Now we're pushing the fact that Pakistan got the bomb mainly because we essentially allowed them to get the bomb, and Pakistan sold it to North Korea. It's no surprise that North Korea is looking at uranium enrichment technology because it came from indirectly the United States.
And we really knew that North Korea was proceeding with a bomb. RCI damn well knew what they were doing. They had to know. If they didn't know, then they were deficient.
That's why I say that instead of the UN issuing these toothless proclamations that are useless and a laughing stock of the world, it should be built up, because we're going to have to face Iran, we're going to have to face North Korea, we're going to have to face God knows how many countries that wants to beat their chests and say that they have the next bomb, because their mortal enemy on the other side of the border has the bomb. And this is the price we're going to pay unless we begin to strengthen the United Nations and diplomacy and negotiations, or else we're going to have to take out all these small nations aspiring to become the next superpower in their region.
Do you think that we're past the danger of nuclear annihilation? We haven't talked about that in a lot of years, ever since the cheerful hide under the desk when I was a kid. Cover up, duck and cover, and all the rest of that. And ever since then, we haven't really talked about that, because we assumed when the wall fell, so did the danger. But
yes, but I think there's two dangers. One is accidental war, because, of course, all these nuclear weapons, they more or less still exist. The so-called dismantled weapons can be remantled almost any time.
Remantled.
And they basically disassembled them. They unscrewed the cap, and they took the nuclear pit out, as they call it. However, they can put the pit back in within a matter of seconds and reassemble these things. So I think that instead of getting rid of the plutonium, we simply stockpile the plutonium for what, God knows. And I think it means that we still have several hundred tons worth of the deadliest material, plutonium, lying around.
How likely is the scenario, I'm sure this has been kicked around plenty, that if there would be a nuke or 2 or 4 or 10 used, India, Pakistan, whatever started it, that then it would be a sort of a join hands thing, and people would align and take sides, and other bombs would start to go off, and before you know it, we're back to that scenario, that nuclear annihilation scenario. Is that possible from something like this?
It's possible things could escalate. Let's say China gets involved, because China is India's big rival.
Yeah.
Okay.
Yeah.
And all of a sudden, we're talking about big powers suddenly being sucked into something and taking sides. Look at World War I. It started with the assassination of an obscure Archduke of Yugoslavia, for God's sake.
Yeah.
And it touched off one thing, touched off another, ricocheted across the corridors of power. And all of a sudden, the entire world was engulfed in World War I. And I think with so many loose nukes around, and with the nuclear weapons proliferating in the most dangerous areas of the world between India, Pakistan, and the Middle East, I think it's not going to be a very pleasant place to be.
How many nuclear weapons? I've always kind of wondered about this, just sort of a civilian question here, but how many nuclear weapons would it take to go off to have a really nasty effect on more or less the whole planet?
Carl Sagan did an estimate of this, and the estimate is that as little as 100 megatons, which is just something but a handful of nuclear weapons,
100 megatons,
would be the lowest number necessary to set off a nuclear winter. Other calculations perhaps put it a little higher. However, at the height of the Cold War, each superpower had about 30,000 atomic and hydrogen bombs in their arsenal. Many times, thousands of times, the number necessary to set off a nuclear winter and block the sun, and we would go the way of the dinosaurs.
What is the biggest bomb we have?
About 20 megatons. At the height of the Cold War, the Russians detonated an 80 megaton bomb.
80?
80, yeah. They claimed it was 100, but it's been recently recalibrated down to about 80 megatons. That was the biggest bomb ever detonated in the history of the world.
That sure is a big bomb.
As a huge bomb. It created tremendous amounts of fallout. It was logged on all the seismographs around the country. It really scared the hell out of a lot of people when that big bomb was detonated. Our bombs tend to be smaller, less than 20 megatons. 20 megatons is the largest of the bombs. And again, that in turn is 1,000 times bigger than the Hiroshima bomb, which was only 20 kilotons, whereas a TNT.
Yeah.
These are pretty powerful weapons. And again, with the Soviet Union falling apart, who knows whether one of these things will eventually wind up on the black market. It only takes one, to create international panic. And the Russians have thousands of these things that they can barely account for. Their monitoring system is very deficient. All sorts of reports have stated that they're loosely guarded. And the Russians, of course, as a matter of national pride, keep saying that they can keep track of these damn things. But it only takes one to fall to the cracks. And these things are very powerful weapons, enough to wipe out the greater New York metropolitan area from Connecticut all the way down to New Jersey. It could wipe out the tri-state area here. Just one nuclear weapon of that size.
One bomb of that size.
Yeah.
For her. Everybody should at least bear in mind, shouldn't they, that if we begin a war, which seems a sure thing now, that it always has at least a potential, perhaps albeit hopefully a small one, of ending up that way.
It's up about that. If Egypt falls or Jordan is destabilized or, God forbid, if Pakistan has a regime change, we're in big trouble. Okay? Like I said before, these terrorists, they see suicide as part of national policy. Okay?
Yes.
And if Pakistan's 20 or so nuclear weapons were to land in the hands of fundamentalists, that would change the entire equation. You think about this. Mullahs, we know fundamentalist mullahs that hate the United States in charge of up to 20 atomic bombs. That really gives one pause.
Oh, it does.
And the government there is not that stable. It's just barely hanging on with its fingernails.
And there's no way you can think right now that charging into Iraq, a full bore, which we're getting ready to do, is justified by what we know so far about what might or might not be there, because it could absolutely result in more harm than safety for the world. That's what it comes down to.
We could be the bull in the china shop. Oh, it's a very delicate balance of power in the Middle East. And God knows where all the tideware is going to fall if the bull starts some kind of big war in the area. If you look at the last Persian Gulf War, the big victor of that war was in some sense not the United States, because, of course, Saddam Hussein survived. The big victor in that war was Islamic fundamentalism. That's where Islamic fundamentalism got its big start, was in the 1991 war, a war fought in the backyard of these fundamentalists. And that was their big shot of the arm when that war took place. And so the winners of war are often not who you think they are. World War I and II were fought between the great German Empire, the great British Empire. But who won those wars was not either Britain or Germany, but it was the United States and Russia. So the people who win these wars sometimes are totally different than the people who started these wars. And I think the big winner of the last Persian Gulf War was not the United States at all. The winner was Islamic fundamentalism.
It certainly has blossomed since then. There's no denying that.
Now, all this talk would have been unimaginable in 1990. Can you imagine this kind of talk happening in 1990 when Jordan, Egypt, Saudi Arabia, Pakistan were deemed stable? Nobody even considered this possibility. Now it's after the Persian Gulf War, and look at how Islamic fundamentalism has grown. And again, the victors of war are often not who you think they're going to be. Okay, and the United States, in some sense, did not win the 1991 Persian Gulf War because Saddam Hussein is still in power. And in fact, it helped to unleash the current wave of anger against the United States.
If we go sweeping into Iraq and come back with the head of Saddam Hussein on a silver platter, or its equivalent, will we have won?
We know we can do it.
I'm saying, will we have won?
I think we'll win the battle, but we may lose the war.
How do you imagine we would lose this next war?
I think every general fights the last war. Okay.
Yeah.
Also, I think we have to look at the next war afterwards. Okay. And unless we begin to put a lid on all these weapons of mass destruction through negotiation, we're going to have to put a lid on these weapons of mass negotiations through war. Okay.
Well, they lie. I mean, everybody lies about it, of course. Proliferation and research and development, they all lie.
In fact, Iran is next. Are we willing to take on Iran? They're beginning to develop these weapons. And what I'm saying is, if these UN proclamations meant something, for God's sake, if the international body politic, nations upon nations, were to say, yes, let's believe in these resolutions and make them have teeth rather than being these teethless resolutions, then perhaps we wouldn't try to curry the favor of the United Nations, but we need it.
But that means the UN has to have teeth, and the members of the UN are chamberlains. They don't have teeth.
I think we've allowed it to atrophy in that direction. I think we sort of washed our hands of it. We think that it's anti-U.S. and therefore we don't need it. And then when we need it, then when we want to have this grand coalition, and then we realize how much it's decayed. See, George Bush needs the United Nations because so many people say that we need to have international consent.
Oh, he needs a rubber stamp.
Well, he needs a rubber stamp, but see that rubber stamp.
Professor, hold on. We'll pick up on this when we get back. From the high desert, I'm Art Bell.
You're listening to Art Bell Somewhere in Time on Premier Radio Networks, an encore presentation of Coast to Coast AM from December 18th, 2002.
What the matter with going wrong? I know. Get my hand nothing.
You're listening to Art Bell Somewhere in Time on Premier Radio Networks. Tonight, an encore presentation of Coast to Coast AM from December 18th, 2002.
Now, with regard to war, you've had quite a number of opinions laid upon you. That would be the opinion of several of you out there, and then one of the greatest minds in our country about war. There you are. Plenty to think about, but far from the majority, certainly, on this issue, but at least he certainly answered the question. Professor Michio Kaku is my guest, and he'll be right back. All right. Hard as all of this is to segue from, I wanted to get the answer to that question from the professor, and I feel like I definitely got it. Now on to some more interesting things in many ways. As a suggestion for the show, the professor said, we might discuss some of the Christmas movies, Harry Potter, Lord of the Rings, Star Trek, and so forth. Whether civilizations in space might be able to master these technologies, as exemplified in these movies. And so we have a number of them here, and I'm not necessarily going to take them in order. Now, I said there was just a big sighting, in fact, CNN had it, of a triangular craft above Baghdad, just like the one that was above Phoenix. Now, let's ask about levitation of machines, the ability of something to seemingly defy gravity. Oh, in fact, let's even start there. Professor, I have the hardest time, and I still don't understand what the hell gravity is. Gravity holds us here. It gives us weight. It makes things drop onto the table when we drop them. But I've never properly understood what gravity really is. It because the Earth has mass and so we're pulled to it? Is that gravity, or what's gravity?
Newton thought that gravity pulled. It was a force that pulls you to the floor, but of course that leaves open the question, what is force? Einstein introduced perhaps the most realistic scenario.
Yes.
And he said that gravity doesn't pull, space pushes.
No.
So if I have a bed sheet and I put a ball, a very heavy rock, let's say, on a bed sheet, everything, of course, sinks into the rock on the bed sheet. And if I then hurl a marble, a tiny marble around this rock, the marble will orbit. And there are two ways you can look at it. You could either say that the rock pulls on the marble, but that's not what's really happening at all.
No, what happened is the rock is making an indentation, so the marble is slowly circling toward and will eventually hit the rock, right?
That's right. So in other words, the bed sheet is pushing on the marble. Not that gravity pulls, but the bed sheet pushes on the marble, deflecting it into the path of a circle. Let's say I have a crumpled sheet of paper and put little ants on a crumpled sheet of paper.
You guys always use ants.
Right. Well, that's because we think that we are the ants. The ants would say that it's impossible to walk in a straight line on a crumpled sheet of paper because there are forces, invisible forces, pulling you to the left, pulling you to the right. Now, we know there's no pull at all. It's just the crumpled sheet of paper that pushes the ant to the left, pushes the ant to the right. Now, this crumpled sheet of paper is space. Space is invisible. That's why we can't see this force of gravity, but it's caused by the curvature of space-time. So believe it or not, the reason why you're sitting in your chair in your living room is not because gravity pulls you to the floor, but because the Earth has warped the space around you, and the space around you pushes you down to the floor.
Are you sure about that? Are you sure that's what gravity is?
We now have satellites that have tested Einstein's general theory of relativity to within experimental error, 1%. Now remember, back in the 1920s, when Einstein's theory was first verified, there were a lot of error bars, and people could still quibble about whether Einstein was really right or wrong with the deflection of sunlight.
Well, then is it the mass of the Earth that is bending or deflecting the space that's providing the pressure? Because obviously gravity is related to the Earth, because when you're not on it, you don't have gravity.
That's right. The more Earth, the greater curvature.
So it is directly proportional and can be measured by the mass, the amount of mass of whatever.
That's right. And of course, for small gravitational fields, this approximates Newton's old theory. But for black holes, we see that Newton's theory has to be thrown out the window. For black holes, we really do see that spinning black holes behave as if you have a spinning bedsheet. If you have a spinning bedsheet with a depression inside, it looks as if you have like molasses being dragged around the black hole, right, around the bedsheet. We see this now. We actually have photographs of this with the Hubble Space Telescope. You can actually see space like molasses being whipped around by the black hole, eating up star systems and clouds of stellar material. You can actually see what is called frame dragging. And again, for a low gravitational field, it's really hard to see the difference between Newton's theory and Einstein's theory. You need stars before you can see the difference. With black holes, it stares at you in the face. You can really see that space-time looks like molasses that's being turned around by a spinning black hole. And we photographed this now with the Hubble Space Telescope. So we now have visual confirmation of Einstein's theory, not just experiments with satellites and laser beams, but visually you can see it.
All right, if we absolutely then understand what the force gravity is, wouldn't that be the first step in I don't know if I want to say defying it, but the first step in eventually defying it or finding a way to neutralize it, or in other words, coming up with something that will float?
You're talking about anti-gravity.
Yes, probably anti-gravity or some understanding of the force that is gravity that would allow us to circumnavigate it or to manage it or to use it as a propulsive device, or you get the idea.
Anti-gravity is very, very difficult because you have negative matter, and we've never seen negative matter. Negative matter would fall up, it wouldn't fall down. We've looked for negative matter of the oceans and the air and outer space, no evidence of it.
We've never seen a bit, even a tiny little negative matter.
No, if there was negative matter in the Earth, this is not antimatter, by the way. Antimatter we think falls down. Okay? Antimatter is positive energy, it falls down. Negative matter, is different from antimatter, would actually fall up. If there was negative matter when the Earth was very young, it would have fallen up billions of years ago and would be in outer space, almost by definition.
You were even deep within the bowels of the Earth, there wouldn't be.
Look at the bottom of the oceans for exotic kinds of particles like negative matter. Now, recently, we've gotten a lot of interest in negative matter because negative matter can be used to drive a time machine. All the recent work of the last decade or so in time machines is because we think that negative matter is so exotic, so bizarre, that you can actually use it as a gasoline for time machines.
Boy, now singing my song now.
Right now, we've never seen negative matter, and maybe in outer space. One day an astronaut may come find negative matter.
What?
We haven't seen it yet.
Well, yeah. What would the nature of, as we understand physics, what would the nature of negative matter be other than the fact that it would fall up, you said? I understand. I can grasp that. It would fall up.
We have a good grasp of antimatter because antimatter is ordinary positive matter with a negative charge, a reverse charge. A proton would have negative charge. Now, anti-negative matter is totally different.
Right.
Negative matter has negative mass, okay? Which is different from antimatter, which falls down.
Negative mass.
Now, we don't
less,
think about it.
That means it's less than a thing. It's not.
That's right. Okay. Now, negative energy, on the other hand, we have duplicated in the laboratory. This was the famous Casimir effect. We have actually duplicated negative energy in the laboratory. Some people have claimed that you could use that for a time machine, but it would be very, very feeble time machine. You wouldn't be able to teleport anything more than a tiny subatomic particle backwards in time. But the Casimir effect already exists, measured in the laboratory several decades ago, in fact. It's very tiny, but it gives you negative energy. If you had negative matter, you can manipulate it, and you could then begin to warp space and time so that this molasses that I talked about would actually bend on itself, and you would get wormholes opening up. The negative matter almost immediately opens up a wormhole in space and time.
If you could get your hands, I'll have to use this I suppose, metaphorically, on negative matter, how would you contain it?
Well, you see, with antimatter, that's the problem, because antimatter annihilates with ordinary matter, and you would blow yourself to smithereens.
That's what I was wondering, yeah.
Now, negative matter, we don't know too much about it. We just plug this into Einstein's equations, and all of a sudden a space warp, and in fact, a wormhole opens up whenever you put a piece of negative matter into Einstein's equations. Think of the molasses again, or our bed sheet. All of a sudden, you have two regions of the bed sheet connected by a tunnel, and that tunnel would be then held open by negative matter. We don't know anything about it. It would be subatomic matter.
Would it be potentially containable in any way you can even imagine?
It's too early to speculate because we have no theory of negative matter other than just putting it into Einstein's equations. If you put it in Einstein's equations, all of a sudden magic happens, and all of a sudden the bed sheet twists and turns and bends on itself. This has been well known for decades, but only within the last decade has been a lot of research because, of course, these wormholes would be time machines.
Yes, if, for example, our astronauts in the International Space Station were to encounter negative matter, which I suppose is more possible there than it is here on Earth since all ours has already fallen up, it probably wouldn't be or possibly at least, wouldn't be an agreeable meeting, would it?
Yes, it wouldn't be too agreeable because if you got too close to us, you may not be able to get back very quickly. You may wind up in a different time era. The negative matter opens up what are called transversable wormholes. Now, let me explain. An ordinary black hole also opens up a wormhole, but it's a one-way ticket. It's a one-way trip through the black hole, and you never come back. The black hole has an event horizon. Negative matter does not have an event horizon. There's no point of no return. They are transversable. You can go back and forth.
Really?
Between them.
Really?
That's why they've engendered so much interest ever since the group at Caltech showed about 10 years ago the first solutions using negative energy, negative matter, showing that they would create wormholes that are quite nice. Transversable, reversible, you can go back and forth and come back.
Well, gee, this is the first I've heard of this. Normally, you've said that time travel would require such immense amounts of energy, perhaps the management of the energy of the sun or better, that we couldn't do it. But if we were to get our hands on some negative matter, all of a sudden we've got a swinging door.
Right. However, that's the trick, though. We've never seen it in the laboratory. We've looked for it. It would be fantastic. It would, of course, have tremendous amounts of potential for practical use. And at the present time, I think most physicists have given up looking on the Earth. We would have to look into outer space and hope that an astronaut could find it, but it's not for us. We don't find any on planet Earth. Everything on the Earth falls down.
Is there much evidence that there would be negative matter even in space? I suppose negative matter could be eternally traveling from one a magnetic influence to another or bouncing off them, whatever it is it would do.
Yeah, it's conceivable. Again, no one's ever seen any, so we can't make any experiments. And negative matter, but by the way, would not fit into the quark model of today. So we would have to modify the quark model, but it's a term that easily fits within Einstein's equations.
If negative matter were out there, let's say there was a ball of negative matter out there, and it was traveling along, would we observe anything about space or the space it was traversing that would give it away?
Let's say the negative matter was spinning in a ring. Then a wormhole would open up, and if you fell through the ring, you may wind up in a different piece of space at a time.
No, but our astronomers, would there be anything about space? Would negative matter be invisible in all probability? Would it be disturbing space to a degree that somebody could notice that anomaly with a telescope? Would we know?
It would warp gravity in a highly unorthodox way, but it would take probably a large chunk of negative matter before it became optically visible. That is, starlight would bend around such an object in a bizarre way. And then you can start to infer that there's something out there. Now, this is how, by the way, we detect dark matter. Dark matter is ordinary matter, but it's invisible, and it makes up most of the universe. We know that dark matter is out there because the Hubble Space Telescope has seen light deflected around galaxies, as if galaxies were surrounded by dark matter. And so here we have something that's actually invisible dark matter, which makes up 90% of the matter of the universe, bending starlight, and we now use that to create maps of dark matter, which surrounds different galaxies.
Are you suggesting to me that dark matter would create a stable portal, theoretically, a stable portal in which to go forward or to go back in time?
Negative matter, right? Yeah, dark matter we think is ordinary matter.
No, negative
exotic form.
Matter would allow this portal near its presence to go forward or reverse.
That's right. The Global Tech were experimenting in their minds, of course, with theory, saying that if I had a little bit of negative energy,
yes,
okay, which of course already exists, we could open up a wormhole, but the size of that wormhole would be less than that of a subatomic particle. So it's kind of a useless device because it's a time machine, but only if it's smaller than a subatomic particle.
But I take it's like a firecracker, the energy as compared to the matter.
But negative matter would be stable, okay? And you'd have to have, again, large quantities of it. But in principle, it would open up wormholes, and the larger the wormhole, the larger the amount of matter necessary to stabilize the wormhole. Okay? And that would then connect two regions of space pod. Anytime you have negative matter, it opens up a wormhole. Frank Tipler once showed that several decades ago. But now, of course, we're looking for these things, and we have theories of time machines that have been proposed. And a quick and dirty way of doing it is applying this already existing in outer space rather than having to create the energy of a star on the Earth.
Yes.
Okay.
Yes.
However, I should point out, once again, we've never seen it. You have to put it into Einstein's equations, and then it opens up a wormhole. But so far, no one has ever bagged such an animal yet. And maybe the space program will one of these days.
Yes, indeed. We're looking. You admit, then we're looking. And if we saw something that we thought was it, we would try and grab it.
Yeah, the way to do it is to look for deflection of starlight.
Right.
That's how we find the existence of passing black holes and dark matter, by looking at the distortion of starlight as measured by telescopes and the Hubble.
Suppose some authorities came to you and said, my God, Dr. Kaku, we have found a region or a small segment of dark matter, and we're going to take a spacecraft to try and retrieve it. How, and they asked you for advice on how you would get and bring back this dark matter.
Negative matter, right.
Negative matter, I'm sorry.
The way to do it is to send space probes. We would have to send instruments.
Robots.
Potentially just as dangerous. You were talking about gravitational effects that we've never seen before in a laboratory. Negative matter, if it falls up, it repels ordinary matter. And
Professor, hold it right there. Hold it right there. We're at the bottom of the hour. We'll pick up. Very, very interesting. Negative matter, if it was whizzing along up there, we'd send a robot to go get it. But then if it was going to fall up, how could we bring it down? That's exactly what we'll ask when we get back. That is absolutely fascinating stuff. A time machine. Coming and going. All we need is a little bit of negative matter.
You're listening to Art Bell Somewhere in Time. Tonight featuring a replay of Coast to Coast AM from December 18th, 2002.
It saves the earth without you on the old. All face it. Don't hold the minutes. Sleeping here in place.
Premier Radio Networks presents Art Bell Somewhere in Time. Tonight's program originally aired December 18th, 2002.
Isn't this something? After all the talk we've had on the near impossibility of time travel, because of the obstacles we'd have to overcome power-wise, we now learn something called negative matter would allow a stable portal back and forth. It would be a time machine. Negative matter. It's just a matter of finding some negative matter, which might be in space. And my question still stands with the good professor, and that is, if he was consulted on how to go get it and contain it and then bring it back home, what suggestions, I wonder, would he have?
And the book of the building. And down. Back down. And down. Back down.
All right, then. It was like in a science fiction novel. All of a sudden, scientists find, through whatever spacecraft we have monitoring such things, that there is some negative matter traversing an area between, say, our moon and the Earth, an eminently available kind of area. So we could get a robot, a spacecraft, up there and scoop up some of this negative, or at least have the opportunity to do so. If they were to come to you and say, Professor, what do we do? Do we scurry it into a lead box? Do we have electromagnetic force fields holding it in place? What would you suggest we do with the negative matter? I mean, we get it. Then what?
Because it is repulsive with respect to ordinary matter, all we have to do is put a net around it. The net would repel the negative matter, but if the net were symmetrical, it would repel negative matter evenly, and you could trap negative matter with an ordinary net.
An ordinary net.
Right. You can't do that with antimatter, because if the net were to touch antimatter, it would explode.
Right.
But you see, negative matter, by definition, is repulsive under gravity. A net around it would repel the negative matter evenly.
You could scoop it up like a butterfly.
That's right. And however, I said before, we've never seen any. We don't know its properties. You would have to send probes into it to test its nature, because it could be quite dangerous, and it could warp space and time in totally unpredicted ways. So I think that a lot of caution would be
admirable.
If at some point in the future we ever got one of these damn things.
Would you recommend that it be put in orbit instead of attempting to bring it home right away?
I think it should be kept at a good safe distance from the Earth, because we don't know its basic properties. We know that planets are held together by gravity. Gravity pulls evenly, and that, by the way, is the reason why the Earth is round.
Perhaps then you'd recommend that it would be landed softly, if possible, on the moon.
Possibly, or simply kept in outer space, because it is repulsive. It would not want to land on the moon. It would want to be in outer space. And we would, of course, want to see whether we could machine it. Okay? And the ideal configuration might be a ring, in which case...
A ring?
A ring, in which case, if you go through the bullseye of the ring, you may find yourself on a different piece of space and time than when you first started.
Different... Oh, no, that's interesting. Not just a different time, but a different space as well. In other words, if I theoretically went through this ring, Professor, I wouldn't just be, I don't know, back or forward a few years or many years, but I would actually be in a different place as well.
That's right. You would be distorted displaced both in space and time simultaneously if you were to go through a wormhole, or what we physicists call a multiply connected space. Think of sheets of paper that are parallel, that are joined at different spots. And these two sheets of paper may exist in parallel with each other, except once in a while they intersect.
Would I live through it?
If you have a large enough, a massive enough object with a large enough wormhole, then you may be able to walk through it. We've calculated the tidal forces when you walk through these things. It's possible that if you have enough of this matter, you could walk through it and not feel anything more than simply being on an airline flight.
What do you imagine that I might step into on the other side?
It depends on how you solve Einstein's equations. Einstein's equations do allow for space to be bent back in on itself. And of course, before we walk into one of these things, we should calculate the geometry of it and estimate to our best degree of accuracy what's on the other side.
Send a cat or two through it.
Right. And then...
But let's a probe.
It would be transversable. So the probe could come back.
And send photographs.
Photographs, right.
You know? What do you imagine, Professor, that we might see in those photographs? Would we see our own world at a different time? Would we see a different world? Would it be a different dimension with a different race of people walking around? What are the possibilities?
It could just be our own universe, displaced dramatically in space and time, a wormhole that simply connects our own universe with itself. Which would mean it's a gateway to the future or a gateway to the past. Okay? And of course, that then gives us the question as to what happens when you shoot your parents before you're born.
Yes.
then you would have a time paradox.
Which you have really always answered by suggesting that we live in a bubble, and essentially another bubble would be created if you killed your grandfather, and there would be then two infinitely continuing timelines that would break off. Is that the only possible answer to that?
Well, the simplest resolution to all these paradoxes is to have the timeline fork. The river of time would fork into two rivers, and two universes would open up, and there'd be no contradictions whatsoever. You could alter your past, but in some sense, it's somebody else's past. Somebody else who looks genetically the same as you, you've altered his past, but your own past is fixed. You cannot really change your own past. It disappears.
Is this an answer we've come up with simply because of the impossibility of any other answer?
The other possibility is that you fulfill the past, but that's kind of boring because then it was such that you were destined to go back in time to complete the circle.
Right.
But it was written. It was destined that you would then go back in time. And then, of course, that leaves the question of free will. What happens if you don't feel like going backwards in time and fulfilling your destiny back in time at some point? Some people have said that maybe great conquerors or scientists were actually time travelers from the future. But then, of course, that raises the question, what happens if they altered their own past? Could they not then make themselves vanish because their own past was impossible because they just accidentally killed their ancestor before they were born?
Is there anything that would happen potentially to the traveler? In other words, if Dr. Kaku stepped through, would his memories of the past and where he had been versus where he is now be intact, or would he simply be part of a new reality in every way, including mentally, just step into what you would feel has always been there?
I would disagree with the science fiction writers to say that your memory is going to change and your whole being is going to change if you create what is called a time quake, that is, go backwards in time and create a time paradox which then ripples back on you into the future. Right?
Yeah.
I think a much simpler solution to the problem is that time forks. Time simply forks into two rivers. And then you don't have any paradoxes. The quantum theory has within it the ability to bifurcate universes. And if the universe splits off, then basically you've altered somebody else's past.
But what I'm saying is, would you be aware that you had done all of
You would
this?
be fully conscious. Locally, according to Einstein, you would be in an ordinary space-time frame. But if you went backwards in time, you would never notice any of these bizarre distortions. Of course, people around you would notice these things. But locally, space looks flat. So locally, time beats normally for you, and you think you're pretty much at rest. Okay. Well, actually, what you've done is you've looked around the universe.
Huh. Is there any rule or law that would tell you when you took that one step how many years or how much space you'd be traversing? Or would it all be just a guess?
It would be a guess. However, in principle, if you knew the location of all the stars, if you knew the location of all the objects in the universe,
Yes.
you could just plug that into Einstein's equation,
Yes.
and then Einstein's equation would tell you at what point in the past or the future you wound up.
Would this be a specific or controllable thing? In other words, would the amount of negative matter always reliably determine that you were going to go back to 1967, for example, every time you walk through, and only an adjustment of the amount of energy or the amount of negative matter would change that?
Of course, it would take a supercomputer to do this calculation, but in principle, if you use the location of the stars, the location of the distribution of negative matter, you could plug this into Einstein's equation, and it would predict where you are going to wind up when you go through the ring. Okay. Now, whether it's tunable or not, that's another question. Whether you can fine-tune it so that you wind up on yesterday, exactly 24 hours previous to where you are.
Yes.
That would require an enormous amount of tuning. And I tend to doubt that you can tune it that much. But all I'm saying is it's probably predictable as to where you're going to wind up. You know, the geometry of these configurations, Einstein's equations are quite explicit. You will wind up at a certain point in space and time that's calculable.
That's incredible. All right. Scientists, as we know, recently have claimed teleportation. They've said that they've teleported, I think, a molecule of light or some such. I can't exactly.
A photon of light.
Photon of light, yeah, there you are. And they've done that. it's a first step, a first really small little baby step, but doesn't that put us pretty close to understanding, an understanding that'll allow much bigger steps?
In principle, the proof of principle is the hardest thing to do. Eventually, we want to teleport an electron, not just a photon of light, but real atoms across this device. And I suspect that maybe within a few decades, we may be able to teleport a virus. A virus is not that complicated. We're talking about a bunch of molecules put together in the form of a virus, and perhaps even teleport primitive life forms this way.
But a virus is a sort of primitive life form itself, isn't it?
Yeah, but the problems are enormous. The technical difficulties involved in what is called quantum entanglement are really stretching the borders of our technology. And it may take centuries before we can do anything more than just teleport a bunch of molecules. So I personally think that teleportation is really for type 1 or type 2 civilizations. We are talking, I think, on a time span of centuries before we can do anything more than just a few subatomic particles. That doesn't help you.
While we're on the subject of viruses, scientists, I just read a story, it's dated today, and it says, within ice that covers a salty, liquid Antarctic lake, scientists have found and revived microbes that were at least 2,800 years old. Now, what they did is they drilled down up in the Antarctica into this ice. I didn't know they were doing that. I guess I did. And I knew they were drilling, but I didn't know that they were reviving. Basically, the scientist was quoted as saying, all you got to do is warm it up and add water. And these things are there and alive.
I think it was 28,000 years. By drilling into the ice cap.
28,000? Well, it says 2,800 here. This is from, I think, Nature. I'm not sure.
Well, maybe you're right. But if you drill into the ice, how far backwards in time you're going, because we can calibrate the ice layers. We know when certain volcanoes erupted, for example, and volcanoes laid down a layer of soot. And by drilling into the ice, you can see these layers of soot as you drill deeper and deeper into the ice. And by this way, you can calibrate how far you are digging.
Absolutely. But I was just wondering, is this really smart?
I think it's not such a great idea, because who knows what kinds of things you're going to find down there. Maybe better let sleeping dogs lie, as they say.
Oh.
Because who knows what kinds of diseases existed back then and whether or not we have any immunity to them. I think we ought to test these on mammals before we begin to unleash these things.
Exactly my thought. That's exactly my thought. I said in the first hour, I also noted then that even if we don't have scientists going up there with their drills and their little heaters, then we've got stories like this. Record melt in Arctic and Greenland. Mother Nature is busily doing it for the scientists. So things are melting like crazy, and eventually one of these little guys is going to melt and warm up all on its own.
I think this is one of the areas where we have to be very careful. Another area where we have to be careful is where scientists are creating artificial life. They're actually taking pieces of cells and taking the minimal number of genes necessary to sustain life.
I read the story the other day.
Right. And I think that that gives you pause, because who knows what kind of bizarre cells you're going to create, and cells reproduce. That's what they do. They reproduce.
And see, they're designing it to reproduce. And in the story, they said that, there might be some danger, but they said, we're specifically hobbling these little guys so that should they jump out of the petri dish, they wouldn't be able to survive in our atmosphere. We're intentionally, in some way, design our little lives so that they can't survive in our environment
until they mutate. And let's say they mutate, so they can't live in an oxygen-bearing atmosphere.
So you're saying that's a possibility?
I think that nature is much more clever than most scientists give her credit for, and there's always a chance that a mutation could rearm or re-enable this microbe to exist at room temperature in a normal atmosphere, in which case God knows what we've unleashed on the world. And again, we're talking about a very small probability, of course, of this happening. But you cannot recall a genetically modified organism. You can recall a Ford car that has a defect in it,
Yeah.
but you cannot recall a germ that has mutated so that it can survive in our atmosphere and under normal conditions, and they will multiply. That's what they do.
Is this enough of a danger, Professor, that somebody ought to go to these scientists and say, hey, guys, listen, you might be, of course they really know, but there is this possibility, and other controls really ought to be in place before we gene mix anything else to life here.
We have to be very careful. In the Arctic, for example, they're digging up corpses of individuals that died during the last flu epidemic of the 1920s. It was one of the greatest flu epidemics of all time.
Yep.
We have no traces of this flu that we can look at with our DNA analysis. We're digging up corpses that are buried in the ice for many decades. And this is being done under extreme conditions, security conditions.
Yes.
Because we don't want this flu to get out because it devastated tens of millions of people last time it got out.
What's the rationale for digging it up?
We want to find out now that we have DNA technology, we can begin to look at exactly what is this that made it so dangerous. We can actually see on the genetic level how it was armed, how the genes armed themselves to the point where it could just wipe out whole populations. It killed more people than World War I.
But you don't think there's any possibility that they would dig it up and then it would be turned over instead of the scientists you would hope it would go to, but it might get turned over to our biowarfare people who would try and figure out how to make it even more dangerous than it is now. They wouldn't do that, though, would they?
Well, it's happened in the past at Fort Detrick.
They would do it?
At Fort Detrick outside Washington, D.C.
They have to.
A whole rogue gallery of different kinds of designer germs, one of which, by the way, almost escaped several years ago.
Really?
That's in the newspapers. And, of course, people said that if it wiped out Washington, D.C., we would, of course, not have any big effect on the nation's politics anyway. But the point is that it is outside Washington, D.C. And we are experimenting with designer germs.
How close did it actually get to getting out?
The newspaper reports are sketchy because, of course, it's been classified. But it's kind of scary. Even the fact that it was mentioned, the fact that there was an incident, gives you pause.
Professor, hold tight. We're at the top of the hour. I just didn't know about that. I wonder how close whatever it is came to getting out. What?
You're listening to Art Bell, Somewhere in Time. Tonight featuring a replay of Coast to Coast AM from December 18, 2002.
Isn't it strange that Dr. Kaku would mention this thing about the simple first genetic structure that we're creating? We're actually creating life. I went off on this for almost a week. I totally went off on it when I read the story, because that's what we're doing. We're getting into the creation business. We are creating life, and to that life, if it could point to its maker, it would point to us. I did. I went off on this whole subject real heavily for about a week. I just was startled when I read this story, and I don't know that it hit everybody the same way, but to me, that was the first step in putting us in the creation business. If you could eventually ask some more complex organism that we would create in the same manner about its creator, it would point right at us. We would be its creator. That puts us in the God business, in the creation business, it seems to me, or at least the first step in that. Is that out of line?
Well, I think that's where it's headed for. I should caution that initially we are talking about tiny microbes that you can't even see, and the chances of this happening are very close to zero. However, you can't rule it out because, of course, mutations happen quite rapidly in the microbial world.
That's what nature does, right?
And that's what nature does. The microbes do mutate.
This is evolution.
That's evolution. That's what we have. Germs that are resistant to antibiotics. They evolve. They evolve to be resistant to antibiotics And these little microbes that we are essentially going to design from first principles will have the minimum number of genes necessary to survive, and they may survive in ways that are totally alien to ordinary life.
Yeah.
And if some of them escape into the environment, who knows what's going to happen?
I do a little, and that's why I went so heavily off on this, and it's not like a lot of people got it. It's like, this is such an incredible thing that's being done right now. I think that a public debate about this is not forthcoming, mostly because the American people are, by and large, kind of ignorant about science.
That's right. However, if you live in Mexico or Latin America, you know all about killer bees. Killer bees were accidentally released in Brazil in the 1950s. A few queens escaped from the station there.
Just to see you.
And these Africanized killer bees then began to displace the weaker European honeybees. And now they're creeping into Texas and they're creeping into California.
Big oops.
And you cannot recall these things. And again, this is an extreme case, but it shows you that life will prevail, that life forms will struggle to survive, and that organisms will mutate to survive in the environment. And even though they can't survive now, perhaps the mutation will make one of these things survive in the future.
Shouldn't there be, I don't know, some kind of public debate? Maybe the public isn't capable of it. Some panel, some congressional or Senate committee looking into all of this or something?
Yes, but unfortunately right now, like you said, most people are ignorant of this problem, and I think some oversight is called for. We are talking about big stakes. It's not just an academic question of some scientist getting their name in the light and winning a Nobel Prize.
Yeah.
We are talking about creating life forms with unforeseen consequences. And again, 99% of the time, it's going to be perfectly safe with nothing to worry about. However, it's that 1% that bothers me.
Bothers me too. For example, let's move quickly to cloning, and that's a close relative. Cloning, oh my goodness, is it moving fast? I've got a story right here that says that, let's see, the race to clone the first human appears to have intensified after claims that a second team is about to begin experiments to clone babies for 7 infertile couples. An announcement that the first human baby clone will be born within a few weeks, made last week by controversial Italian fertility expert Dr. Servino and Torre, was greeted with a mixture of skepticism and contempt. But now his former partner, Dr. Zavos, has dismissed Dr. Torre's claims and announced that instead he is pursuing his own program with a specialist in animal cloning, a professor at a European university, and he says he is just about to clone himself, a human, and then store it in nitrogen at an undisclosed location, or that it already is, and is about to be used. And he's going to create the clone. So here we go.
Right. See, we know that it's possible to clone a human. That's known. The problem is you have hundreds of defective embryos and fetuses that are created, horribly deformed creatures that will never see the light of day.
Monsters.
And it's a hit or miss process. And we've now genetically looked at the genes of cloned animals, and we find hundreds of mutations. And of course, you can't see them visibly when you look at a cloned sheep or a cloned pet. However, we know at the genetic level that hundreds of mutations are introduced. So this is unethical. We are creating, if you clone a human, you would have to create hundreds of deformed embryos, and the human that is born is going to have hundreds of mutations in them, and it is totally unethical. And just because some idiot scientist wants to have their name in the newspaper, we're going to see these scientists perform unethical experiments. And I personally think it may take decades before we iron out this hit or miss process by which the cloning process takes place. Now, in the recent Star Trek movie, that's also based on cloning when Jean-Luc Picard's DNA gets cloned. But that's in the 23rd century, okay, where they have plenty of time, hundreds of years, to iron out the defects in the cloning process.
Having said all this, though, do you doubt for 1 second that they're really in Italy or wherever right now they're doing this?
There probably are. However, these unfortunate women will give birth in January to deformed fetuses. If they even reach that far, these individuals will probably be horribly deformed. And I think at that point, people are going to be shocked at the brutality of these scientists who just plunge ahead with this very untested technology. So I think we're playing with life here. We're not just doing a science experiment to get your name in the newspaper. We are talking about life, and this life will be deformed. Sad to say.
What's going to happen?
However, at Stanford University, I think they've taken a more measured approach. All they want to do is clone stem cells, embryonic stem cells, and that in turn can open up a cornucopia of new therapies to cure diabetes, cure heart disease, cure diseases of the kidneys, spinal cord injuries.
Well, why should we believe that stem cells could be cloned safely without serious mutation if your thought is to use these stem cells in research and cures, which I'm sure it is? Why should we imagine they would be cloned any more safely than Dolly or Harry or Antonio in this case?
To take an adult cell that's already differentiated into skin, for example, and you have to do violence to it so that it reverts back to its embryonic state and then it starts to reproduce. You have to do a tremendous amount of genetic violence to an adult cell to do this. Embryonic stem cells are embryonic. They naturally, practically naturally want to develop into different kinds of or tissues of the body. And we're not talking about some genetic violence that is done to adult cells that have already differentiated. We're talking about stem cells that naturally want to become kidneys and pancreas cells and lung cells. And I think that within 10, 20 years, we will see the beginning of a human body shop. Already we can begin the process of cloning skin, bone marrow to a degree. And I think within 10 years or so, perhaps the first liver or portions of liver will be grown in the laboratory, unless, of course, the Bush administration puts a halt to these.
That was going to be where I was going to go next. There's a big controversy about it. They say stem cells can only be obtained from fetuses, right?
And they're going to be discarded anyway. There are literally thousands of these fetuses sitting in liquid nitrogen vats from fertility clinics. They're going to be thrown away, and they're going to be discarded and flushed down the toilet or put into a trash compactor.
And the most, or the strongest argument that you could muster that we should not do that would be
that we're talking about a new generation of medicine. Medicine that simply doesn't try to stimulate the immune system, but medicine based on replaceable human body parts to extend the human lifespan, to increase longevity, to make the human life more fulfilling. Look at Christopher Reeve. Here's a vital individual that's just sitting there immobilized because his spinal cord is severed near the top.
yes.
We can grow new kinds of nerve cells with embryonic stem cells if the government will provide funding for this new technology. This is proven in the Petri dish. We want to then prove it with animals and eventually with humans. And it's a technology that's sitting there unless ideologues get their hands on it, in which case we're going to have a brain drain. Not a brain drain to America, a brain drain away from America. It's just going to go where the funds are, and the funds are going to be in Europe. And the funds are going to be in different countries which do not have ideologues that are deciding science policy.
You do understand the sensitivity to it.
I understand. I also understand the precious nature of human life. And why should we condone suffering? Why should we condone human suffering when it's needless? Within our own family tree, think of our relatives who are suffering from debilitating diseases. In fact, for example, diabetes will be an epidemic as baby boomers start to age. They have, of course, an awful lifestyle. They're overweight. They load themselves with sugar. We're going to see a massive explosion of diabetes, which is going to drain our Medicare system. And it could break the bank when baby boomers start to age. Wouldn't it be better to simply grow new Isles of Langerhans for the pancreas of these individuals so it doesn't break the treasury of the United States? Look at the cost of medical care in this country. It is skyrocketing. And it's going to get worse as baby boomers start to age and as their pancreas wears out and they become diabetic and they become blind and they have to have their toes and fingers amputated. Look at Mary Tyler Moore. She's diabetic. She may go blind very soon. And she's worried about that possibility. And why? It is totally unnecessary.
When we could be turning out pancreases by the tens of thousands.
Right? Hundreds of cells that are going to be thrown away. Think about that. Discarded. Thousands of these fetuses sitting in fertility labs and baths of liquid nitrogen. One day, somebody will simply turn off the temperature control of these liquid nitrogen baths, and these fetuses will simply decay at room temperature. And that's it. All these cells could be regenerating nerve cells, pancreases, kidneys, lungs, skin, bone.
Conceivably, any human part.
That's right. There are 200 different kinds of tissue in the human body. All 200 perhaps can be grown in the laboratory to extend the lifespan and eliminate human suffering. Why should people suffer? That's the bottom line, I think.
That eclipses all in your mind. At all. We should just proceed ahead. There should be no control over this at all.
I think there should be oversight, because, of course, some individuals will be tempted to bring one of these clones to maturity, in which case you have all the ethical problems of human cloning, and you have all the ethical debates with regard to whether or not somebody will steal a piece of your skin and clone another individual that was just like you without your permission to ourselves, as somebody stole some of your hair follicles.
Oh, they'd be working on it now. So oversight perhaps, but not a full stop. We should definitely proceed with this, and that would be any human part of it. You could grow a new arm.
But take a look at lizards. Lizards grow new arms. We've seen lizards with their arms broken up. How do they do it?
I don't know. You're the scientist. How do they do it?
They do it with stem cells. That's how Mother Nature does
Do
it.
they really? Is that what they're using?
They use. This is as natural as stem cells found in nature. Nature does this all the time. We generate organs for salamanders and frogs and lizards. Of course, we separated from them about 500 million years ago, so we lost that capability. But other life forms regenerate whole organs. They do it with stem cells.
Of course, a lot of people say, look, if God had meant us to regrow an arm, if we lose one, then we damn well have more stem cells in our body, and our bodies would do it. God didn't intend for that.
Well, in which case, let's go back to the caves and turn off sanitation and medical care and not have MTV anymore. If God wanted us to have MTV, he would have put its TV monitors in our eyeballs.
A lot of people would lose their arms before they'd give up their MTV.
And the point is, this is a natural technology. Nature uses stem cells to regenerate organs in the animal kingdom. It's as natural as nature.
I heard, I think earlier actually in tonight's show, I read a kind of an interesting thing to the audience. I wish I could find it here. Here it is. Scientists got together, several scientists, decided they could do anything that God could do. They could change weather, create life. They met with God and told him he could leave, that we didn't need him anymore. God said, let's have a contest. The one that makes a man first wins. If I win, I stay. If you win, I leave. Scientists agreed. God reached down and picked up a handful of dirt. The scientists reached down and picked up a handful of dirt. God said, no, get your own dirt. Did you get that?
I think I got it.
But you, as a scientist, you'd rather not deal with that particular question, I take it, would you? The question of, well,
We physicists are the only scientists who can say the word God and not blush. So bring it on.
in other words, that isn't even a concern. As you move forward with science, at no juncture will you ever consider, would you ever imagine that you would have to consider God in any way? Only the perceivable scientific danger to man.
The ultimate question is, where did the laws of physics themselves come from? Okay? And at that point, of course, you can argue the Big Bang, you can argue inflation and different kinds of cosmological scenarios, but that all occurs within the framework of physical law. And then when you ask the question, where does physical law come from? Then you have big problems. And that's where some scientists invoke God.
Yes.
Now, Einstein got around the question by saying that God had no choice in creating the universe. The universe is unique. There was no other way to create a universe. And in fact, we think that basic philosophy is correct. It is extremely difficult to create a universe. We try to do this with our equations. 99.99% of the time, our equations fall apart when we try to create a stable universe. And the only thing which seems to work is string theory. The only game in town, and it seems to be this unique theory that gives us a universe. And then, of course, you may ask the key question. If you're so smart, then, you scientists, where did these string equations come from? And at that point, we just throw up our hands and say we don't know. But know that perhaps they are unique. They are the only game in town. You cannot create a universe in any other way. But why not have nothing? Why not have nothing instead of something? Well, the very fact that we are here discussing this question,
Yes.
that something has occurred, that is intelligent life exists, which means that the universe was set into motion. We do have stable protons and stable DNA, stable enough to create life and consciousness. And that, to me, means that a universe must have enormous constraints on it.
But you really wouldn't hesitate to get into the God business, would you? Or what many call the God business?
I would hesitate to create new life forms because we simply don't know what the hell we're doing.
Or would you just not call it the God business?
I would not get into creating new life forms because Mother Nature has had millions of years to iron out all the problems. We've only had a few months to iron out these problems of cells that we're creating out of a test tube.
All right, Doctor. Well, I guess you just say, well, hey, it's my dirt too. Let's start even here. Or probably wouldn't imagine the conversation in the first place. From the high desert, I'm Art Bell.
You're listening to Art Bell, Somewhere in Time. Tonight featuring a replay of Coast to Coast AM from December 18th, 2002.
After a swim and over a burning, with a minute of radio and read military start. You. Jeffrey did. Oh, Jeffrey did.
You're listening to Art Bell, Somewhere in Time on Premier Radio Networks. Tonight, an encore presentation of Coast to Coast AM from December 18th, 2002.
Dr. Michio Kaku is here. On the dirt thing, have you ever heard such a pregnant silence in your whole life? It was silent. We'll get right back to Dr. Kaku. Once again, Dr. Michio Kaku. Dr. Kaku, welcome back. In a lot of areas, we really are approaching what a lot of people consider to be the creator's arena of things. And I take it that, being serious here for a second, you really wouldn't stop yourself from proceeding for that specific reason. You would rather do it because of real scientific danger in proceeding in some of these areas.
That's right. When we scientists play gods, I think that in terms of theory, like the Big Bang, the unified field theory, string theory, it's okay for scientists to imagine being God, to create a universe out of our equations. However, equations can be recalled. Organisms cannot. And I think that if we create new life forms, most of the time they're going to be harmless. They will not survive, and so there's no big problem. But they mutate. I think we have to be extremely careful that one of these days, just like the killer bees that escaped from this bee station in the 50s at Rio de Janeiro,
Something's going to get loose.
I think that something could get loose. And I think that
I'd use it for something almost did get loose, and you alluded to it, so well, it's classified, and we can't really talk that much about it. How much do you actually know? Do you know more than you can talk about?
we just know that at Fort Detrick, outside Washington, D.C., which of course houses much of the desired germs that we've been playing with, even in spite of the 1972 biowarfare treaty that we signed with the Soviet Union, that there was an incident that took place years ago where it almost escaped. And we have many biosafety levels there. The people there look like people from a space movie with all these gloves and spacesuits to protect themselves from germs.
Right.
And it only takes one mistake, one careless mistake for some germ to escape from that laboratory. And that's the price we pay for playing, tinkering with germs, Ebola and Rift Valley fever, dengue fever, and different kinds of germs for which we largely don't have cures.
You heard about this nasty little thing going around on cruise ships, this Norwalk thing. It's kind of puzzling. It seems to be affecting cruise ships, and again and again, despite all the scrubbing and everything, we just keep hearing about these new ships coming down with this Norwalk thing. And
well, apparently, 100, as little as 100 particles of the virus are enough to set off this Norwalk-like illness. And you can't even see 100 viruses. And that's all it takes to be placed in the nose of a test subject to induce the symptoms or to ingest it into your stomach. So I think we're talking about something that is very common. It's one of the most common illnesses in the United States, but it doesn't propagate very far because those people don't spend weeks at a time in a cruise ship. A cruise ship is the ideal incubator for these things.
There's something I was going to bring up. A cruise ship is like a little enclosed environment, protected in the long run by miles and hundreds of miles of salt water. It's just isolated out there on the water, and why something, it would be almost the ideal place to test something, wouldn't it?
That's right. In fact, when European cities got off the ground 5,000 years ago, that provided an ideal environment for ancient illnesses that we've always lived with. These diseases are millions of years old to propagate in cities because of the close contact that we've had.
Of course, I'm not saying they're doing it. Of course, I'm just saying theoretically it would be.
I think it's natural. I think that they traced it to a few individuals that came on board with the illness that infected everybody else. It just takes one individual to infect the entire ship. And I think that's the price you pay for being in this confined environment, which is ideal for germs, and they propagate like crazy. A handshake, a sneeze, fecal matter, anything in the air could set this thing off.
But you and I talked a lot about black holes before, and here's an interesting Associated Press science article. The headline says, "Telescope sees black holes merging." In a looming collision of giants, two supermassive black holes are drifting toward a violent merger and an eruption of energy that is going to warp the fabric of space. It is all happening in a bright galaxy only 400 million light years away. Now, under, I guess, found this X-ray observatory is 400 million light years away, a nice, safe distance to observe a couple black holes hissing.
That's right. The nearest galaxy to ours is only 2 million light years away. And we think that galaxy that you mentioned is a byproduct of two colliding galaxies. When two galaxies collide, their black holes begin to dance around each other.
Really?
And if you take a look at Andromeda, actually, our closest neighbor, you actually see two blips in the center, which means that Andromeda probably ate up another smaller galaxy years ago. And by the way, our galaxy may be on a collision course with Andromeda. And the future of our own Milky Way galaxy may be to have a hostile takeover.
Awesome.
And the atoms of our body may very well wind up in the center of Andromeda, orbiting around the black hole at the center. So Andromeda apparently has eaten other objects in the past, and we see that in the belly of the galaxy with our radio X-ray telescopes. And that's where we may wind up eventually, if in 10 billion years we actually collide with Andromeda, which is about twice as big as our galaxy.
If a collision of that sort occurred, I think we would see it coming for a very long time.
Really 100 years. I wouldn't worry about it. However, it would be quite dramatic seeing Andromeda get bigger and bigger with time and seeing the two star clusters collide, basically. Individual star collisions will be rare because, of course, the galaxy is basically made out of nothing. But when stars do collide, it would be spectacular. And when the two black holes at the center collide, it would be quite something. The black hole is at the center of our own Milky Way galaxy.
Can you imagine an Earth involved in such a collision? When the time got near, what would be the first things that somebody like yourself imagines would begin to occur that we would notice?
Well, we would notice the fact that dust clouds are colliding with other dust clouds, heating things up. And as we got closer, we would see the blackness of outer space glow because, of course, clouds are much larger than stars. And stellar collisions would be quite rare, but we would see a framing of dust clouds in the sky, and we'd probably see a few stars passing by us as we got closer. And the sun goes around a black hole, which is at the center of the Milky Way, and that black hole and the black hole in Andromeda would be gravitationally attracted to each other, and they may execute this dance that we see in this galaxy that's human, which is much older than ours, we think. And we think that, yes, our atoms, too, may eventually wind up in the belly of Andromeda. We may be a very big lunch for that galaxy.
But physically on the Earth, how would it proceed? Would it be a slow but sure change, or would there be an instant of catastrophic ending?
Oh, it would be very gradual.
Very gradual.
Our sun will probably turn into a red giant in 5 billion years. And so way before that, way before we get eaten up by Andromeda, our sun will actually begin to get larger and the sky will be on fire. So it's not going to be pleasant when the oceans boil, the mountains melt, and the sky's on fire. And even within a scale of 1 billion years, the nearest astronomical catastrophe is when the Earth's wobble around the sun starts to get larger and larger. You see, the moon is leaving us slowly but surely, and the moon helps to stabilize the spin of the Earth. If it wasn't for the moon, the Earth would have spun like a gyroscope that's out of control.
Now, I knew about the moon, but I didn't know it was leaving.
Yeah, the moon is gradually leaving us because of pilot force. It's a very slow leaving of the Earth. We can actually measure that, by the way, with laser beams. We can shoot laser beams off the moon and calculate how far the moon is to within a few inches to a few feet.
Well, is there ever a moment where the moon will get far enough away from us that all of a sudden we release, in essence, its hold on us? The amount of mass is only so much, the amount of gravity is so much, and its hold suddenly gets released and the moon just goes...
The moon will always be influenced by the gravity of the Earth. However, it'll get farther and farther away from the Earth, and it will cease to stabilize the Earth, and the Earth could begin to wobble quite dramatically in 1 billion years. And we think that Mars, by the way, is entering that phase, is already in that phase. And we think that the polar caps of Mars weren't always the polar caps of Mars. And this could be done with supercomputer calculations. They can calculate what the Earth is going to look like billions of years from now. And we know that after about 1 billion years, the moon will be so far from the Earth that the 23-degree tilt of the Earth that gives us summer, fall, winter, spring
Yes.
could wobble quite dramatically.
Wobbling is probably not good.
Not good at all. It could mean that the pole caps could move as the Earth begins to spin in different directions. So the Earth has been quite stable for 4.5 billion years because of our moon. However, that's not going to last forever.
Would the passage of another planetary body of equal or greater mass than the Earth itself, a nearby passage, also cause this kind of wobble? Just theoretically,
Theoretically, yeah, it could definitely tug on the Earth. We do know that when stars explode or what have you, there's a possibility the planets could be set adrift, and we wouldn't see them. They would be dark planets just drifting in out of space because they are no longer tugged by their own star's gravity. And this is purely hypothetical.
they would become rogue planets.
It would become rogue planets, right? And if they came by the Earth, yeah, definitely it would cause the Earth to wobble out of its orbit. And it would create huge catastrophes on the Earth. Flooding, the weather would go berserk, earthquakes, large portions of the Earth crust would gradually begin to shatter. It would not be very pleasant if a nearby planet came close to the Earth.
And these nearby these rogue planets do indeed theoretically exist. In other words, they're not under a major influence of any particular body at all. They simply are
basically been released from the gravitational pull of their mother star. And again, I don't expect to see this happen, but if it were to happen, we would have very little notice because planets do not give off light. And so anything wandering in the vicinity of the solar system could definitely
we wouldn't see it.
The Earth.
We wouldn't see it coming.
We wouldn't see it coming. That's right.
Until when if such a thing would occur, Professor, would we ever see it? I assume that we would. In other words, as it got within a certain distance, our astronomers would begin to notice, just where did the light from that star go? At some point, wouldn't they?
It'd be very difficult. We would notice that the Earth's orbit was gradually being perturbed. That 365 and a quarter days was no longer the span of the year. And we would have very little notice. Now, of course, scientists have also found the wandering black hole in our galaxy. That is more noticeable because it works starlight. And that's how we identify this wandering black hole, by looking at the bending of starlight as it moved. A planet, however, would not do that. A planet would not bend starlight. It would be totally invisible. And it could creep up right next to it, so we never know it. And again, I don't expect that to happen. We're talking theory that there could be rogue planets out there.
We certainly are. All right, I'm going to squeeze in a couple calls here. First-time caller line, you're on the air with Professor Kaku. Hi.
Good morning, gentlemen.
Good morning. Where are you?
I'm in Walton, Kentucky, and I've been wondering about gravitational effects on mass and its other form, energy.
Mm-hmm.
If you had, say, a mass of 1 gram and converted it to energy, would the gravitational effect on that mass survive that transformation?
The gravity would be the same. Gravity responds to both matter and energy. So the gravitational tug, which is very small, from a gram of matter, would equal the equivalent energy, which is the energy of several hydrogen bonds, I think, that would be released. And again, it would be very small, but according to Einstein, the gravitational effects are indistinguishable from a distance between matter and energy. They both enter in the equations in the same way. And in Einstein's equations, matter and energy are almost interchangeable. So the gravitational effects will be identical. So when we look at the sun, this actually becomes a practical question. How much of the energy of the sun contributes to the gravitational tug of the sun? And there we have to factor in the energy and the matter when we calculate the gravitational pull coming from the sun.
Well, what about this force known as quintessence? Does that have anything to do with this, or is that an entirely different thing?
There are many theories of dark matter, and it makes up 90% of the matter of the universe, we think. And quintessence is one possible candidate. We don't know for sure what dark matter is made out of. We just know that it's invisible. It surrounds the Milky Way galaxy. It makes up most of the universe in terms of matter. And different theories have been proposed, among them quintessence and other theories. My own personal point of view is that string theory has higher harmonics, higher octaves, and a higher octave of the string would be invisible. And that probably makes up most of dark matter because they're stable. The photon, for example, is a leading candidate for dark matter right now. It's stable, it's invisible, it's predicted by the theory, and it could make up most of the visible universe. But again, all bets are off because we simply don't know what dark matter is made out of. We know it's out there. We can photograph its effects with the Hubble Space Telescope, but we simply don't know what it's made out of, which is very embarrassing. That most of the universe is made out of something we don't have the slightest clue as to what it is.
But that probably holds for us then a very bright future, at least a possible bright future, because when we do discover the nature of it, then of course we'll be on our way to ultimate control of it.
That in the far future, once we understand the mechanisms that make all these things work, that is the unified field theory, in the same way that we manipulated Newton's laws of gravity to design machines.
Professor, we're almost out of time. I want to ask you this. We've been, you and I have been talking for years now, and, I'm about to retire December 31st, and I just wonder, we've had so many talks about type 0, type 1, type 2 planets. As you observe the state of the world today, are you more or less encouraged, or even discouraged perhaps, that we are going to graduate to type 1 or blow ourselves to smithereens before making the leap? How do you feel today at this?
Well, I think I'm a little bit more pessimistic than before. However, I think there are two competing trends. One trend is negative. That is the greenhouse effect, the fact that we're not going to a solar hydrogen economy, the fact that nuclear weapons are proliferating. But the positive effect is that we are gradually having an internet, which is creating a global connection between all peoples of the earth. And we are seeing the birth of a type 1 economy, a type 1 culture, a type 1 language, which will be English, and the beginnings of a type 1 civilization. So I think it's glorious that we could see the beginnings of a type 1 civilization right before our eyes with the internet, with the European Union, with globalization. And however, there's the downside of globalization. There's the downside of the greenhouse effect. And there's the downside of not going to a solar hydrogen economy.
So all things considered, my question was, given the current state of the world and the direction that we can all see that we're going in, you think, in all probability, we're going to lose the race?
Well, I think it's going to get worse before it gets better. I think it'll get so bad at a certain point that we're going to have to rein in these weapons. We're going to have to rein in the greenhouse effect. We're going to have to eliminate oil, but only when it gets so bad that the average taxpayer, the average voter says enough is enough. But I think it's not, we haven't reached that point yet. The average person is not so frustrated that they're going to get out there and vote with their pocketbook to rein in the greenhouse effect and rein in these weapons and bring on a solar hydrogen economy. We're not there yet. It's going to be a close call.
Where we are, though, is the end of the program. So for all these millions of words that you and I have shared, thank you so much over the years. And again, thank you, for being here tonight.
My pleasure.
Take care, my friend. Good night.
Okay, good night.
That's Professor Michio Kaku. That's it this night from the High Desert. I'm Art Bell. Y'all have a good night. Good night.
For the melody, don't you hear a melody? Don't you love anybody? Don't you want you?